Okay, here we have problem 53 from chapter 8. Now we have a capacitor which has a 9 microfarad capacitance. Then it has a charge on it. It's 3 microcoulomb when there is an A between the plates, so it means K is equal to 1. The plates are separated by 2 millimeters, and with a charge on the plates kept constant, the electric with K is equal to 5 is inserted between the plates. So now after that they insert a dielectric with a K is equal to 5. That one is completely fills the volume between the plates. Now in part A we have to find what is the potential difference between plates before and after inserting the dielectric, and what is the electric field at the point midway between the plates before and after the dielectric is inserted. Now okay, so we have first of all a general formula where Q is equal CV, right? First of all, we have to find electric potential before and after inserting dielectric. So that means we can say that V initial is equal Q initial divided by C initial, okay? Or just the Q or C. The Q is equal to 3 microcoulomb and C is equal 9 microfarad. Now if you divide them, so 3 divided by 9, it gives you 0.333. So 0.33 volts, okay? Now then after that we have to find electric potential after dielectric is inserted. Now we have a couple of formulas for that case. The first one will be actually V final is equal V initial divided by K, okay, when this is for the V. Now we also have for the electric field, similar basically, electric field final is equal electric field initial divided by K, okay. Then we also have for the energy final is equal energy initial divided by K. These are the formulas that we will use, but however we can just use the first one. So we found the electric potential before the inserting dielectric. Now we have to find electric potential after inserting dielectric. So initial was V initial over K. So V initial is equal 0.33 volts divided K is equal to 5. Now divide by 5, you'll get 0.066 volts. Okay, this is electric potential after inserting the dielectric. Now we have to find electric field midway between the plates. Now electric field between the plates, whether it's the middle, whether it's close to plate, it doesn't matter, it's always the constant, okay? Now then let's find the electric field before and after inserting the plates. Again, we have a general formula where E is equal V over a D, okay? Since we're trying to find E initial before inserting, so E initial is equal V initial over a D distance between the plates. V initial was 0.33 volts, the D was 2 millimeters. So if you do calculation, 0.33 divided by 2 multiplied by 1000, so you should get 161 volt divided by meter. Then after that you can find the E final using the formula where we had E initial divided by K constant, or dielectric, which is inserted after that. So that means initial was 165, then K was 5. So now if you divide by 5, you will get 33 volt per meter. Now this is one way. The other way to find the electric field after, it will be just E final is equal V final divided by D, okay? They will get the same answer basically. Here was V final was 0.066 volts and D was 2 millimeters, so again you should get 33 volts per meter. This is how you solve such a problem.